Hi, Professor Wellman. This is Erin O'Neill, and I will be talking through Quiz 6, problems 1 through 4. So, to answer number 1, what is the electric field between the plates? The magnitude and direction. So, what we have here is a 9-volt battery connected to a capacitor, which is two different plates that are storing the potential energy from the battery. So to find the energy field between the two, you need to take the volts of the battery, divided it by the distance between these two plates, because that's where it's existing. And so when we do that, we get 9 to the 7th, or 9 times 10 to the 7th power volts per meter. And we know that the top plate is the positive one, the lower plate's the negative one, and since the direction of the electric field is directed in the direction of a positive test charge, or the direction that a positive test charge would be pushed or pulled if placed in space surrounding the source charge. So it's basically being pushed or pulled to the negative charge. So the direction is going, in this case, down towards the negative charge. And then what is the capacitance? Try saying that word 10 times fast. Just kidding. So the capacitance is easy enough to find because the equation is this right here. I forget how you say this, but the permeability of free space times the area of only one of the plates divided by the distance between the two plates. And so I entered those numbers here and I got 3.159 times 10 to the negative 6 powers F. And then for 3, what's the charge on each plate? Charge is just the capacitance times the volts. So when I multiply what I just got for the capacitance times 9 volts, then I know that one plate is positively charged 2.8435 times 10 to the negative 5th coulombs, and the other one is that negative charge. And let's see, number 4, what is the energy stored by the capacitor? So the potential energy can be found through this equation, which is half of C times V squared, which when just tossing those previous numbers in, I get 1.279 times 10 to the negative 4th joules of potential energy. And I think that's it. Thank you.